The Central American river turtle, Dermatemys mawii. A gentle giant of the waterways of Central America. As one of the largest freshwater turtles in its region, adults can measure over 2 feet in length and weigh up to 50 pounds. These turtles represent an ancient lineage 65 million years old. But these amazing creatures are disappearing. The Central American river turtle, or Hicatee, is a critically endangered species of freshwater turtle endemic to lowlands in Central America. They are one of the top 25 most endangered turtle species in the world. The sweet meat of this herbivorous reptile has been consumed by indigenous populations for centuries, and the insatiable appetite for tortuga blanca has brought it to the brink of extinction. Historically, Hicatee could be found throughout Central America. Today, most local populations have disappeared and are restricted to a few remote pockets in Mexico, Guatemala, and Belize. Hicatee are the only extant representative of the family Dermatemydid, a sister taxa to the family Kinosternoidea, which includes the musk and mud turtles of the Americas. Ancestors of this family date back to the Jurassic and were distributed through what would become modern-day Europe. The Jurassic period was the age of the reptiles. The supercontinent of Pangaea had already begun to divide during the Triassic and continued to split during the Jurassic. By early Jurassic, Pangaea had become Laurasia in the north and Gondwana in the south. Continents continued to separate and spread, and by the late Jurassic, Laurasia had separated into North America and Eurasia. Gondwana split into eastern and western halves, and Africa and South America continued their migration. Division of the continents led to more coastline, and the climate shifted from dry and cool to warm and moist. Deserts became rainforests, and ferns, cycads, and conifers dominated the landscape. The Cretaceous was a period of rising seas and warm temperatures worldwide. No ice existed at the poles, and elevated ocean levels resulted in many shallow inland seas. In North America, the Western Interior Seaway divided the continent into eastern and western halves. As the Western Interior Seaway retreated, a rich collection of fossil turtle species were deposited at a site known as the Hell Creek Formation in North Dakota. 2 genera from this formation have been recognized as the earliest known stem organisms for Dermatemys mawii, the genus Hoplocheles and the genus Agamphus. To date, the Hoplocheles specimen is the most complete remains of a Mesozoic Kinosternid, consisting of a nearly complete carapace and plastron. This fossil find places the origins of the Kinosternoidea clade in the North American continent during the late Cretaceous. The Cretaceous ended with a bang, quite literally. When an asteroid collided with Earth near present-day Yucatan, it triggered events that resulted in one of the greatest extinction episodes of all time. The KT extinction wiped out over 75% of plants and animals. Despite massive extinctions worldwide, turtle clades survived remarkably well, and a majority made the transition from the Mesozoic to the Cenozoic era. The first true members of the Dermatemydid family date back to the late Paleocene, early Eocene. A recent fossil discovery in Wyoming was given the genus name González-Porter and is the oldest genus in the family Dermatemydid. Paleontologists estimate that the occurrence of this turtle species coincides with the Paleocene-Eocene thermal maximum, a time which is characterized as one of the warmest on record. During this thermal maximum, the mean annual temperature in the Wyoming region from which González was recovered was between 70 and 80 degrees Fahrenheit, with precipitation averaging around 45 inches a year. Today, the same area receives less than an inch of rain annually, and temperatures drop below freezing for over half the year. The extremely wet conditions of the thermal maximum were ideal for Gonfalonidae turtles. Shell morphology, such as a relatively flat and reduced plastron, suggests they walked along the bottoms of lakes and rivers. A widened entroplastral suggests they were also avid swimmers. Both swimming and bottom walking are characteristics that they share with their extant relatives of today. Gonfalonidae is only represented in the fossil record early in the Tertiary period, and is thought to form the base of a monophyletic group of turtles that originated in the early Tertiary. The beginning of the Eocene continued with the Paleocene-Eocene thermal maximum, and was the warmest period in the Cenozoic era. The temperature difference between the equator and the poles was relatively small, and tropical flora and fauna were found at high latitudes. Warm temperatures worldwide created ideal conditions for reptilian radiation, and many ancestral turtle genera are associated with the Eocene. Two genera that appear in the Eocene are recognized as ancestors of Dermatemys: Nodomorpha garmani and Baptomys wyomingensis. Nodomorpha appears first in the fossil record, dating back to the late Wasatchian. Fossils from Nodomorpha have been found throughout Wyoming, North Dakota, and New Mexico. Baptomys appears next during the mid-Eocene and radiates throughout Wyoming, eventually reaching Colorado in the late Eocene. The three species of Paleocene-Eocene turtles did not co-occur, but demonstrate a morphocline in body shape and size from the early to the late Eocene. Gonfalonidae, the oldest of these turtles, had a thick, robust shell and is the smallest. Baptomys, the youngest species, has a thin shell and is very large. Nodomorpha falls in between these two in both size and shell thickness. These gradual changes in morphology reflect adaptations more suited to open water swimming, as seen today in Dermatemys mawii. The distribution of stem Dermatemys from the Cretaceous through the late Eocene suggests intercontinental dispersal from south to north, a pattern relatively rare among North American fauna. Researchers suggest that these turtles migrated north, following warmer habitats made available by the Paleocene-Eocene thermal maximum. Starting in the Cretaceous, a gonfus migrated from New Jersey and was in the Carolinas by the Paleocene. This migration continued along the Gulf Coast, and Gonfalonidae arrived in Wyoming by the early Eocene. Nodomorpha, followed by Baptomys, continued to radiate out from Wyoming and reached Colorado by the end of the Eocene. At the end of the Eocene, the thermal maximum came to a close and temperatures dropped rapidly. Arid conditions prevailed, and Gonfalonidae, Nodomorpha, and Baptomys disappeared forever. Temperatures continued to drop through the Oligocene, and permanent ice sheets began to form and spread throughout the Antarctic. The Dermatemys clade is absent from the fossil record during the Oligocene and does not appear again until the warmer weather in the Miocene. The genus Dermatemys appears for the first time in the early Miocene. During this time, the Gulf coastal plain consisted of a series of freshwater rivers and canals, ideal habitat for an aquatic turtle. Paleoplant records suggest the region had a neotropical climate, similar to Dermatemys' present-day range. Sites in Texas associated with the Toledo Bend local fauna contain fossil remains of turtles that are morphologically similar to the living species Dermatemys mawii. These remains are the first and only fossil record of the genus Dermatemys from the Miocene. No Dermatemys fossils have been recovered from any time period following the Miocene. Despite a lack of specimens, Dermatemys migration into Central America can be inferred from paleoecological records. The Pliocene and the Pleistocene were a time of extreme cyclical climate changes, alternating between glacial and interglacial periods. Ice sheets extended from the north as far south as the mid-latitudes and covered up to a third of the Earth's terrestrial surface during peak glaciation. Cold-intolerant animals, such as Dermatemys' ancestors, were pushed south by dropping temperatures. Dermatemys migrated from North America along lowlands and may have been in Veracruz, Mexico, by the Pliocene-Pleistocene transition. Once in Mesoamerica, populations evolved in situ by dispersal and vicariance. Vicariance is the process by which populations are separated by some event and evolve independently, leading to two or more disjunct but phylogenetically related species. Mesoamerica also experienced cyclical changes in climate that alternated between warm, wet periods and cooler, dry periods. During warmer periods, rainfall was abundant and rivers and lakes were connected by floodwater. Dermatemys were able to disperse long distances to previously inaccessible bodies of water. When water levels fell during cool periods, Dermatemys were unable to cross terrestrial barriers, and isolated populations evolved in situ until the next climatic shift allowed dispersal. The sea level was also affected by glaciation, and shorelines oscillated throughout the Pleistocene, contributing even further to patterns of connectivity and disconnectivity among hydrological basins in Mesoamerica. Finally, the formation of mountain chains during the Pleistocene further contributed to periods of isolation. This pattern of dispersal and vicariance is partially responsible for the present distribution we see today. One of the biggest influences on Dermatemys' population structure has been that of humans. Although the exact date is a topic of debate, humans migrated into the Americas approximately 11,000 years ago. Archaeological records indicate that Dermatemys mawii were an important part of native Central American culture for thousands of years. These turtles were not only consumed, but were a symbol of life-bringing rains. Tombs of high-status individuals are accompanied by burial offerings of Dermatemys. Dermatemys shells and bones have been found in several Mayan temples and archaeological sites associated with the Olmec culture. A sculpture of a Dermatemys turtle was discovered in the Mexican Basin more than 350 kilometers from its known distribution. Actual turtle remains were recovered from Copan, Honduras, also well outside the turtle's known distribution. These findings indicate that Dermatemys have been a subject of long-range transport by humans for thousands of years. Dermatemys are still important to Central Americans today. Unfortunately, overhunting and illegal trapping have pushed this turtle to the brink of extinction. Let's hope this turtle clade, the same one that dates back to 150 million years ago, survived the massive KT extinction and played it cool during the last glacial maximum, will not succumb to the hands of humans.